Greetings, I'm the New Hampshire Energy Geek, and this is the third in a series of videos about some connections between COVID-19, energy, and climate change. We've been discussing the fact that COVID-19 has been growing exponentially. Here are some figures on the deaths from COVID since December 31st, 2019. This first graph is the world confirmed deaths. The next one is the world and US, then China and the US, Italy and the US. Notice they're all the same J-shaped hockey stick curve. It is rather unusual for humans to see such a graphic example of exponential growth, sometimes called geometric growth. Though sometimes hard for us to see, exponential growth is one of two natural growth patterns. The other, arithmetic growth, a straight line on a graph, is the addition of a number over that fixed period. If we look carefully, we can see these patterns everywhere. We find both of these patterns in nature. Bacteria, prokaryotes, and rodents, to name a few, grow in a J-shaped curve, while mammals grow arithmetically. Actually, arithmetic growth is more of a sideways S-curve. Let me explain. When times are good, a population expands. When they are bad, it shrinks. Every ecosystem has a carrying capacity, which is the number of a particular species, called a population, that it can support. Plenty of food, water, shelter, not too many predators. Times are good and the population grows, till it reaches a limiting factor, like lack of food or water, disease, or more predators, and then it shrinks, till the pressure is relieved and it can grow again. A great example of this can be seen in data taken from the Hudson's Bay Company over 90 years of their numbers of pelts of both snowshoe hare and lynx collected each year. And what you see in this chart is you see a rise, a J-shaped curve of the snowshoe hare population growing in blue, and then you see a rise in the lynx population. There's more for them to eat. As the rise in lynx population comes a crash in the snowshoe hare population, and the cycle starts all over again. Notice that the sharp rise, the J-shaped curve we've been talking about, is always followed by a sharp decline, a crash in the population. This always happens in nature. This connection, this relationship between the snowshoe hare population and the lynx population keeps the ecosystem in balance and keeps it at its carrying capacity. For the first million or so years, until around 1750, human population, which is subject to similar limiting factors, grew in this arithmetic S-shaped curve. At the time of the Industrial Revolution, human population began to expand exponentially. Just to give you an idea of the impact of this exponential growth in humans, and to give away my geezer status in case you hadn't already figured it out. I was born in 1951, and according to the Almanac, there were 3 billion people on the planet then. Now, in 2020, there are 7.8 billion people on the planet. My generation is the first in human history to see population numbers of humans double in a lifetime, and they've almost tripled, as we said. So one way to look at COVID-19 is that it is a limiting factor in the growth of human population. It certainly is. And this puts it into a bit of an ecological perspective. One final thing before we close. Exponential growth in humans is not without its effects. In this graph here, you can see the J-shaped growth of human population, and with it, you can see the J-shaped growth in energy consumption. And in the next set of graphs, you'll see a variety of measures of socioeconomic data, and then some data about Earth systems, and you'll see in each one a J-shaped exponential curve. We'll discuss more about this and its effects in the next video. I hope you found this informative and maybe interesting. Take care, and I'll see you next time. Bye.